Let's talk about a hotfix that we have in J inventory. Hello everyone, this is Ali Reza. Welcome to the Mentor Code Lab. When I was writing the J inventory block entity and especially the J inventory screen handler, I was thinking like when we are writing a normal inventory in a block entity and we want to instantiate a screen handler. However, things are different because guess what? Here we have a connector and not a normal vanilla way of a list of item stacks as an inventory. Because of that, our implementation in the screen handler was wrong, and when I came back to my main mod and started writing the gem cleaner, it didn't work. Simply didn't work. It wouldn't even open the inventory and it wouldn't happen to fall back inside the init method on our screen renderer. So even if I would put a breakpoint here, it would never hit, okay? However, if I open the GUI right now, you see that working. So we had a hotfix and I didn't record the video because I was not sure what was the problem. But when I found what was the problem and fixed, I thought to myself that, you know what, people who are following this video tutorial and especially are thinking about these sort of library systems need to be aware of this fact. So let's take a look at the block entity itself. There is nothing new here. There was nothing that needed to be changed here. However, the screen handler. Now, when we are instantiating a screen handler, we are calling constructor. Normally, you would have this constructor that is accepting an inventory and a block entity. You would call this one from the block entities, it create menu, but we will have another one that has a payload and payload alone without anything else. This one is being called when you are registering the screen handler inside the registry system during mod loading. Problem is that when we were doing this overload, we were sending null as inventory. And I thought that, okay, if you're registering a screen handler and you don't need an inventory at that time, so null would be okay. However, that was exactly the problem. So question is, if we are a vanilla solution with a list of item stack, we can easily retrieve that list because guess what? From payload, we will have the block entity because the player inventory gives us the player gives us the world, and the payload gives us the position. So we can retrieve the block entity and we can simply cast the block entity to be an inventory, or and if we implement the inventory interface, or we can cast the block entity to our block entity type and then call a method and retrieve the inventory and then send the inventory to this overload. Simple as that. However, when we are dealing with our system that we have a connector, things change because we want to make sure that we go as easy as possible for the user. Yes, I could force the user to write an overload for the payload all the time and do some coding in it so that each time they have a screen handler, they would need to retrieve the block entity, typecast it, get the inventory, all of that. However, using the system we have right now, the screen handler is just this. Implement two interfaces, one for the payload, one with the block entity, and just call it super. If you don't have any variable here that you need to adjust, just call it super. Everything will work. So let's take a look at what needed to be fixed. The overload with block entity is exactly what it was. However, I moved the add slots before calling the open. That's important. The order of operation here is really important. So we want to have the slots when we want to call the unopen. Other than that, I did add these two overloads for the constructors and we will take a look at them later. However, in the case of payload, you see that after sending the player inventory and the payload, I'm sending a class type of our block entity. So basically, I'm calling this overload. And this is exactly why I had added these two. I thought that I didn't need two, but then when I came back to the game, still didn't have the correct behavior, so I implemented all four of them. For the users, they just need these two. So to get the class type of the block entity, as I said, we can have the block entity. We have the player word. We can get the block entity from payload position, and then simply we get the class and we typecast passed it to the class of the type T because T is a block entity. So we are calling this overload. Okay, let's take a look at this one. In this overload, it's exactly like calling super. However, if I would call super, it would go into the abstract screen handler, and the super would call this overload on the abstract screen handler. And this is why I had to override these two methods here. I need to handle the highlighted constructor myself inside JInventory screen handler. So yes, I had to overwrite this overload and call this instead of super. So we are now calling this overload because we are just calling a new cached block entity with the class type. So that's it. In this guy, the whole magic is happening. First, we are calling this with type sync player inventory. And then, as you see, we retrieve the block entity from the cached list. If we have it, then we retrieve it. If we don't have it, we add it and then send it back. So apply for the player inventory with this position. This returns a block entity. So here we are calling this overload. But then for the inventory, things are different. Normally, you would think that, hey, what the hell? Just get cache the block entity here again and, convert the type and then get the inventory from it. So what is this client inventory connector? Well, we had written it, but let's talk about it. If I go into copy of, you see that it returns a client inventory connector of simple inventory. This is a class that is not the server-sided inventory connector. The difference here is that we have a pair of mapped direction and any type of simple inventory, okay, as an entry, because that's the inventory connector. When we get the sided inventory, we have map direction and simple inventories. Now take a look. The storage add inventory. Now the storage here is a client inventory connector of simple inventory, okay? And honestly, this only extends inventory connector. So we go on top of that. However, we are not retrieving the inventories. We are adding a new inventory, and this inventory is a simple inventory. That's critical here. In the inventory connector, we can have different types of inventories, like output inventory, like predicate inventory, like, I don't know, synced inventory. None of them are understandable by Minecraft vanilla code. The only thing that Minecraft understands is this simple inventory. So what I'm doing here is that I'm retrieving each one of those inventory types and basically converting them back to be simple inventory. Because on the client side, we are not dealing with the logic of what can accept what. Is this inventory extractable or insertable? That is happening on the server side by gem cleaner, a screen handler. So a screen renderer doesn't care about it. It just needs to know how many slots it has and what is in each slot. Because of that, we can easily convert everything to be a simple inventory and then add it to this new storage, okay? In other words, this single line of code will convert all of our inventory types to be simple inventory on the client side. Now that we have it, we need to retrieve that simple inventory. Because of that, we had to add an interface, iInventory provider here. Now, iInventory provider normally had just these two because these are inventory providers. But I thought that instead of generating a new interface, I can just add this here. This will return just the inventory connector itself. Get inventory connector. If it's inventory provider, then it can retrieve that. I could call it iConnector provider, but I wonder if I had something like that inside another library and it was generic. So I'm trying to avoid using that and be dedicated for the inventory. Because of that, I just added this method inside iInventory provider, and here I said that now the T needs to block entity, but at the same time it needs to be an inventory provider. So now that we know that the T is extending inventory provider, I can just call this method on T, and that means that when I get this guy, it returns a T for me, so I can call the get inventory connector. The get inventory connector will be our main inventory, and then we retrieve it here and use it here. As simple as that. Don't forget, here we will not add anything or remove anything. We are just rendering things. So we don't care about the type of that inventory anymore. Instead of our block entities inventory, actually we are returning this client-sided inventory one. And this did the trick. Finally, when we right-click on the block, it opens the GUI easily. And by doing this, the JInventory library is finished. Now, I'm telling you from experience that it was one of the hardest ones compared to the gas, heat, molten, and fluid and energy. Now, transfer network, pipe network is totally different story. But other than the pipe network, others will be easier than inventory, because in inventory we have to deal with simple inventory and other stuff, and it becomes confusing, especially when it comes to this scenario. But in other times it is not as hard as what we had here. We will go way faster and easier because now we understood the inventory and the connectors of inventory type. Now, for example, the energy will be a connector, but instead of having an inventory connector, we will have a fluid connector and an energy connector. And guess what? It's almost identical to this guy. The only difference is how we address the fluid storage instead of inventory storage. And energy is the same thing. When it comes to gas, heat, molten, pressure, these four are a little bit different because we need to handle our own registry entry and make decisions on the behavior of the transferring. And then when it comes to the connectors, they are blazingly fast, identical. It's most of the time copy paste. Now, before we wrap the video, I need to say that I removed the client package here and moved everything to the root, and then made a screen and moved these two to the screens. Same thing happened inside inventory. I think I was putting the screen handler under the client. That's wrong. The screen handler is not client side, so it's under a screen now. Other than these few changes, nothing has happened anymore. For the GUI, I may go on and add 2 more textures for the fluid markers. I'm debating on that. I'm really trying to not do that. I don't know why, because I have these markers sitting on the left side. What if we want to draw them on the right side of the tank? In that case, we don't have the option. So it's just opening the Photoshop and just dropping 2 more textures inside here and adding those 2 textures on top. But the fluid widget will still use the left hand side. I may add a flag there. I don't know. As I said, I'm all into having easier life coding later than right now in the library. I prefer having a complex Boolean logic in the library that makes the user's life easier just by using a method call and flag everything correctly. In the next video, I think I will wrap things up for the GUI and the JInventory, because to me they look final right now with minor tweaks on the GUI, as I said. And then I want to talk about the fluid, because energy is a third-party application right now. It's a third-party library, but fluid is being handled by Fluid API inside the Fabric API. And because of that, I will put fluid first, then energy later. When we finish these two, actually, I think I will bypass these 3 right now and the pressure, and I will take a look at Machina, I think, because this guy will handle the energy, the fluid, the inventory, and then later on the gas, the heat, the molten, the pressure. As we go forward, it becomes bigger and bigger and bigger inside one single class, because let's face it, I want a machine base class that can handle everything. It's not a lot of overhead to have an empty list, so who cares if I add, 10 lists to a block entity class that are all empty. God knows how many of these we may have in the vanilla code. If you like these videos, please subscribe to the channel, hit the like button, and turn on that bell so that when I publish a new video, you will get informed. Have fun, everyone. Bye.